Hi, my name is Jovan Popovic. I'm a Senior Program Manager working in Azure Synapse Analytics. I will talk about Azure Synapse Analytics SQL On-Demand service. This is a service that can help you to analyze data on your Azure Data Lake storage or Azure Cosmos DB and create reports using T-SQL language. First, let's see what is Azure Synapse Analytics. Currently, we have Azure SQL Data Warehouse that is renamed to Azure Synapse Analytics. This is modern cloud data warehouse and it is currently available as a GA product. There is also a new flavor called Azure Synapse Workspace that has Azure Data Warehouse capabilities and some additional features like Studio that helps you to analyze your data, Serverless SQL On-Demand endpoint that enables you to analyze your data on Azure Data Lake storage. It includes Apache Spark, pipelines, link services, and all other things that you will need for data analytics in Azure. In this session, I will talk about this Serverless SQL On-Demand endpoint in Synapse Workspace. Let's first see what is Azure Synapse Analytics Workspace. Azure Synapse Analytics Workspace is an integrated environment that contains everything that you will need for big data analytics in Azure. It contains Azure Synapse Analytics Studio, that is a web tool where you can put your SQL script, notebooks, reports, and all services that you want to analyze. It provides both SQL runtime engine and Apache Spark engine, so you can use either SQL or Spark to analyze your data. You can use Serverless SQL endpoint where you don't need to provision any resources. You can just run a query and pay only for the queries that are executed. Or you can provision resources and create fully provisioned SQL pool or Apache Spark pool. Synapse Analytics Workspace has all features that you will need to implement your data analytics solution. It integrates management, security, monitoring tool, metadata, and enables you to integrate with any data that you need. Focus of this session is Serverless SQL endpoint that enables you to analyze your data in Azure Data Lake Storage and Azure Cosmos DB. There are three recommended scenarios for SQL Serverless. Basic data exploration is a scenario where you have some data on Azure Data Lake Storage or Azure Cosmos DB collections, and you want to explore what is inside to see what kind of data you have, what kind of data types, and to get information what kind of reports you want to create based on your data. Logical data warehouse is relational layer on top of your external data sources, where you can create a set of external tables and views that actually reference Parquet files, CSV files on Azure Data Lake Storage or some containers in Azure Cosmos DB. SQL Serverless enables you to do simple data transformation and read data from different data sources and convert them to CSV, Parquet files and store them on Azure Data Lake Storage. So SQL Serverless is also a good solution for easy data transformation where you don't need full Azure pipelines to do some ETL. Here is one typical scenario for Synapse SQL On-Demand. In most of the cases, you are using Azure Data Factory or Azure Pipeline to read data from various sources and write data as Parquet or CSV files in Data Lake. Once you load your files into Azure Data Lake, you need to explore what is inside. Synapse SQL On-Demand enables you to explore content of your files with SQL language. You can create views over files, join different tables or different files on Azure Data Lake Storage, and create complex reports that you can show in Power BI or any other reporting tools, or just use ad hoc queries using Azure Data Studio or Management Studio or any other tool that can query Synapse SQL on demand. Once you create your views, your client tools will not see differences between the views that are created on internal database tables and on remote Parquet or CSV files that are placed on Azure Data Lake storage. Another interesting pattern is enriching data in Spark and serving with SQL. When you load your data in Azure Data Lake storage, you can use Apache Spark in Synapse Analytics to enrich data, perform some advanced machine learning, and transform your data. As a result, you can create tables in Apache Spark to access your data. In Synapse Workspace, every external table in Spark is automatically copied in Synapse SQL on demand. This enables SQL-centric tools like Power BI, Azure Data Studio to have the same view on the data that is transformed with Apache Spark and to create reports and ad hoc queries on the data that Apache Spark transformed. Another interesting pattern is connector for big data. Synapse SQL has standard T-SQL endpoint. This means that any client tool or system that can talk to SQL Server or Azure SQL can also use Synapse SQL. As an example, if you have SQL Server or Azure SQL managed instance that can use link services, you can use link services to connect to your Synapse SQL endpoint. Then you can analyze your data in your Azure storage using link server from your SQL Server or Azure SQL managed instance using Synapse SQL as query engine. Synapse SQL enables any client tool or system that understands T-SQL to connect to Azure Data Lake or Azure Cosmos DB. Now we will see how you can do data exploration on Azure Data Lake using Azure Synapse Workspace. When I create my Synapse Workspace, I can see properties in Azure Portal. The most important things are SQL endpoint that I'm going to use to connect to my workspace. Synapse Workspace enables me to use Synapse Studio, that is integrated environment where I can see all my data sources and scripts or notebooks that I want to use to analyze my data. In Synapse Studio, I can see all databases that I'm using, which might be SQL on-demand databases, Spark databases, or I can see link services as Azure Data Lake storages or Azure Cosmos DB collections. Databases and link services represent data sources that I want to analyze. If I go to my Azure Data Lake storage, I can browse my Data Lake storage containers and find data that I want to analyze. In this case, I have a container with multiple subfolders where I can see that I have some files. I can use select top 100 rows query to see what is the content of my Parquet file. SQL on demand will go to this file, parse it as Parquet file, and show me what are the results inside. This way I can do easy data exploration of my files on my Data Lake storage. Here we can see the key features of SQL on demand service. First, SQL on demand is completely serverless service. There is no pre-provisioning or scaling. You don't need to specify how many data warehouse units or cores you need to use to process the queries. SQL On Demand will analyze your query and dynamically determine how much compute power it needs to complete your query processing. You need to pay only for service when you use it. When you run the query, you will pay only for terabytes of data processed in that query. There is no additional cost if you are not using this service or if you are not running the queries. Synapse SQL On Demand has T-SQL language and TDS connection. This means that it is highly compatible with standard SQL language that enables tools like Power BI, Azure Data Studio, Management Studio, Link services to connect to SQL On Demand. This means that you can use any tool that understands T-SQL to use Synapse SQL On Demand to query external data. Key features of SQL On Demand are Open Row Set and external tables. Open Row Set is existing T-SQL function that enables you to query external data in tables or in files, and it returns set of rows. We are using Open Row Set as a fundamental feature for exploring external data. Open Row Set function is enhanced to enable you to more easily query external data on Azure Data Lake storage and find what is inside of these files. Second feature is external table. External table is a table that is created on top of external files. It enables you to virtualize external data sets and build logical data warehouse on top of your external data. Another important feature of external table is that external tables are synchronized with Apache Spark. So whenever you create table in Apache Spark in Synapse, the same table will be materialized in SQL On Demand. So you can have multiple tables in multiple compute engines that are referencing the same data. So you can choose, do you want to analyze your data using Spark Python, Spark SQL, or if you want to use standard T-SQL, you can use SQL On Demand to query the same data. Here is an example of Open Row Set function. Open Row Set function in Synapse SQL On Demand is enhanced, and we have added several syntax elements that enables you to more easily analyze your data. First, note that in Open Row Set bulk path, you can use wildcards. This means that you can reference multiple files. So in this case, I'm referencing any file on Azure Data Lake in folder year equals something, with subfolder month equals something, and then I'm referencing any file that has CSV extension. With these wildcards, you can reference different files in different locations. Open Row Set will read all files that are referenced using this wildcard expression. Another important thing is with clause in Open Row Set. In classic Open Row Set in SQL Server and Azure SQL, you need to specify a file format to define what is the schema of result set. In Synapse SQL, we are enabling you to define schema of your files within the query. So here I can say that I want to return two columns, cases and dates, that are type int from this CSV file. Another important feature is column position. So imagine that I have columns in CSV files placed on second and fourth position. If I don't want to return all columns from my CSV file, I can specify column position after the column type, and Open Row Set will return only second and fourth column in this case. Another important feature is ability to reference wildcards in predicates. There is a new file path function that returns value that is matched with wildcard expression in file path. We can use this expression to filter out some values. In this example, I want to analyze all files in year equals something, month equals something folders. But in where clause, I'm specifying that I want to have file path, that is first wildcard, to be equal 2017. And I want second wildcard to be 10, 11, or 12. This is important because OpenOffset can do partition elimination based on this criteria. OpenOffset will not read all files that are referenced with this wildcard pattern because it will first evaluate what are the values in where clause. So in this case, it will actually read only files from folder year equal 2017, and it will read data from folders month equal 10, month equal 11, and month equal 12. This partition elimination based on wildcards and file path is a very important optimization technique because OpenOffset will read less data if you specify what subfolders it needs to read. Another important feature is that you can use these file paths in any part of the query. In this example, I don't have year and month in my CSV file, but I can use file path 1 and file path 2, that are numbers of year and month, as any value in my query. So I can do something like group by year, group by month, and I can return values of this file path 1 and file path 2 expression as year and month in my query. This is very important in scenarios where you have some column values that are not physically stored in the files, and you need to extract part of the file paths as any other column in your query. Another important feature in Synapse SQL On Demand is external table. External table enables you to create a table where physical data is stored on some external file location. In this case, I'm creating table population with 4 columns, and I'm referencing CSV files in the file pattern defined in location value. I'm using data source, that is my storage, my Azure storage, and file format, my CSV format that I defined as external file format and external data source. External tables are fundamental features for building logical data warehouse, because with external tables you can reference any external data source like file or collection in Cosmos DB and represent these external concepts as regular tables to your clients. Any Power BI dashboard or any other client will just see a table without noticing that actual data are placed outside of database. In addition, you can create statistics on the table by referencing table name and table column. Statistics are very important for query optimizer to pick the right plan in the complex queries. In this demo, we will see how to build logical data warehouse and how to use external tables to query external data in Azure Data Lake Storage. Instead of using OpenOffset function, I can create external tables on top of Azure Data Lake Storage files. In this case, I'm creating 3 tables: ADLS product, ADLS retail sales, and ADLS store demographics on top of my file placed in products, retail sales, and store demographics folders. And all files have Parquet file formats. Once I create these tables, I can just select data from my table and I will get results from my Parquet files. This way, I can create complex queries on top of my Azure Data Lake storage files. I can start with simple query that selects everything from one file and I will get the list of all products. I can join data from retail sales files with data in products files by joining ADLS retail sales and ADLS products table, add some where clause, doing some group by, and I can create a new report. SQL On Demand enables me to use full surface area that exists in T-SQL, so I can use window aggregates with rollup clause and use rich T-SQL surface area to create complex reports on top of my data stored in Azure Data Lake storage. I can take these queries and put them in any tool like Power BI, Azure Data Studio, and show reports to my customers. Another important scenario that is a big pain point for most of the customers in Azure is how to do analytic on non-relational or non-database datasets. One example is Cosmos DB. Cosmos DB is a globally distributed database that enables good performance in classic OLTP scenarios with low latency. But if you try to run some analytic on reporting on Cosmos DB, and if you have a large amount of data, analytical queries will take a long time to run and will be resource intensive. Running something like Power BI reporting or Apache Spark directly on Cosmos DB storage might cause a huge performance impact on Cosmos DB OLTP workload. Many customers are trying to solve this problem by separating OLTP and OLAP queries. We've seen that many customers are using some pipelines or workflows to extract their Cosmos DB data to Azure Data Lake or even SQL Server or Azure SQL Database, where they can use some tools like Spark or Synapse SQL to query exported data and run some reports. This way, Apache Spark or Synapse SQL or reporting tools will run only on data set that is exported to Data Lake, and it will not impact Azure Cosmos DB storage. The challenge in this solution is how to orchestrate this solution. Customers need to export data and to ensure that data is always up to date on Data Lake storage, and also to ensure that format of data in Data Lake is optimized for analytic. Cosmos DB Analytical Store is introduced to solve this problem. Cosmos DB Analytical Store is internal storage that is used by Cosmos DB to automatically export data from main Azure Cosmos DB containers into analytic optimized store. Any tool that is running on Cosmos DB Analytical Store will get analytical data without impacting Cosmos DB main storage. Synapse Link is a component in Azure Synapse Analytics that enables Synapse Analytics to directly access analytical store in Cosmos DB. If you have some user applications that are writing data in Cosmos DB containers, Cosmos DB will automatically synchronize this data and put it in analytical store. All data will be exported as some Parquet file that are optimized for analytic. Now, if you need to run some analytic on this internal analytic storage, you can use Azure Synapse Analytics. Azure Synapse Analytics and SQL On Demand can directly query Cosmos DB analytical storage. Tools like Power BI, Azure Data Studio, Azure Analytics Service can run queries that select data from OpenRowSet function, and OpenRowSet function will read data directly from analytic storage. This way, we are combining the best from OLTP and OLAP workloads because we are enabling customers to keep inserting data in Cosmos DB transactional storage, and we are doing analytic using Synapse SQL on demand, using SQL language and analytical store. In this demo, we will see how we can do analytic on Cosmos DB data using Synapse SQL on demand. With SQL on demand, I can use any tool like Azure Data Studio to explore data in Cosmos DB. As an example, I can select top 10 documents from Cosmos DB account in this database by specifying the key and specifying collection that I want to explore. This query returns 3 results from products container in Cosmos DB collection. I can change collection to browse data in retail sales container, and I will get results from this new container with all columns that exist in this collection. I can use standard T-SQL surface area to see what are the columns in my Cosmos DB collection. As an example, in this case, I will define a query that returns 0 rows from open row set that reads from collection orders, and I will use sp describe first result set to return all columns that represents property in this collection. In these results, I see what are the properties that exist in orders collection in this Cosmos DB account. With SQL on demand in Azure Synapse Analytics, we can run complex queries on Cosmos DB collections. As an example, I can use my openRowSet function to read product collection and explicitly specify what are the properties that I want to read from my Cosmos DB collection. In this case, I want to read ID, product code, wholesale, and CPU values. And I can also specify what are the types of the properties in Cosmos DB collection. In the example below, I can see properties from my Cosmos DB container that I want to read. Once I have this query, I can easily create a view that selects results from this openRowSet query. I have created view Cosmos DB product that just reads data from openRowSet function that reads from product collection. Now, if I select everything from my Cosmos DB product view, I will see the same results that my openRowSet function returns. The true power of SQL on demand is the fact that I can combine multiple data sources. In this case, I have view Cosmos DB retail sales that reads data from a retail sales collection from Cosmos DB container, and I'm joining this data with products table that is placed on Azure Data Lake storage. I can join these tables, apply any operator like group by, order by, and do analytics the same way as I'm doing in classic SQL databases. Another important feature in Synapse SQL on demand is easy data transformation. Synapse SQL on demand enables you to easily read some files from Azure storage and transform them and store them as new data set on Azure Data Lake storage. This way, you can take some CSV files that you already have on Azure Data Lake storage, read them, and just write them as Parquet files. Or you can read your Parquet files and split them into multiple partitions. This solution is very useful when you need to create some cache of data. You can run report on multiple data sources, do some aggregation and some reporting, and then you can store results of your query to some location in Azure Data Lake storage, so you can directly read this cached data later. Data transformation in Synapse SQL on demand is used with create external table as select command. In Synapse SQL On Demand, you can run command create external table, Parquet population, that is the name of external table. Specify what is the location where you want to create this table, what is the data source and what is the file format, that can be Parquet or CSV. Then you can run some query like select star from CSV population, and SQL On Demand will read results of this query and store them into location that is referenced by this external table. You can simply read entire content of some file, or you can do some complex reporting like reading data from file, doing some group by aggregation, and then storing results into some file. In this demo, we will see how to use CETAS to export data to Azure Data Lake Storage. Synapse Analytics SQL On Demand enables us to perform simple ETL and store the results of the query to some location in Azure Data Lake Storage. In this example, I have created external data source that references target Azure Data Lake Storage where I'm going to save results, and I have defined file format as Parquet with snappy compression that will be used to store result of some query. Now I can create a schema that will contain tables that will cache results of some queries, and then I can create a table that will be populated from the results of this query. First, I'm going to execute this query to validate that my report is valid, and I see that I'm getting the results. Now I'm going to execute this create external table with specified data source where I'm going to save results, location that represents the folder where the results are going to be saved, and file format that will be used to store results. This table will be populated with the result of this query. This table represents a cache for this report, so now I can just execute select star from cache report. I can see results that I got in the previous query. If I go to my data lake storage and refresh source, I will see that I have folder cache with Parquet files that represent results of this query. Now let's talk a little bit about distributed query execution in SQL On Demand. I mentioned earlier that SQL On Demand is serverless service. This means that you don't need to provision data warehouse units, cores, or any other resources when you provision Synapse Workspace. SQL On Demand has only one component that is called SQL Frontend. That is one instance of SQL Server engine that waits some query to be sent from some client application. This SQL component called SQL Frontend contains metadata as definition of all databases, definition of all external tables, definition of all logins and users, and their roles and permissions. The main purpose of SQL Frontend is to accept the SQL query, check could current user execute this query, and do some initial compilation of the query. When SQL Frontend accepts the SQL query, it will create some initial compilation plan and send this compilation plan to the engine that we call Distributed Query Processing Engine. Distributed Query Processor is responsible for executing distributed SQL plan that will read data from multiple data sources, combine them, and process SQL query results. Distributed query processor breaks user query into SQL fragments that can be executed on distributed query engines. Distributed query processor will decide how many SQL backend nodes is needed to process the queries. In this case, we are using compute power that we have in Azure Cloud to provision SQL backend engines that will read data from Azure Storage or Cosmos DB. The number of SQL backends depends on complexity of plans. If you have simple query, probably one SQL backend will be used to read data and return results. If you have complex queries that join multiple tables from multiple data sources, doing many group by operations, joins, and other processing, DQP will allocate more SQL backend nodes to process the queries. SQL backend queries are getting the parts of the SQL plan, and each SQL backend will execute some part of the distributed query plan. Some SQL backend nodes will just read data from Azure Storage. These backend nodes will just read Parquet or CSV files that contain data that need to be processed in the queries. Then these nodes will send data to other SQL backend nodes that can do joins between different data sets. And this information will be again sent to other SQL backend nodes. When all SQL backend nodes finish processing of the query, the results will be sent back to SQL frontend, and SQL frontend will return result to some client application. This way, any client application as Power BI, Azure Data Studio, or custom .NET application will see only one SQL endpoint, and SQL On Demand will allocate some number of SQL backend engines that will process query in distributed manner and return result to the client. This is different than a SQL provisioned model, where you can create your data warehouse or your SQL pool and allocate some number of data warehousing units that will predefine how many SQL backend nodes will run in the background to process the queries. In serverless SQL On Demand, distributed query processor is responsible for determining how many backend nodes is needed to complete one query. Another important feature of Synapse Analytics is metadata sharing. Parts of Synapse Analytics are Apache Spark and Synapse SQL. So these are two runtime compute engines that you can use to analyze your data in Azure Data Lake storage. Apache Spark enables you to use Spark Python, Spark SQL to create some external tables, perform some machine learning, and reach data. And as a result, you will probably create some table on top of your data lake storage. There is a problem with SQL-centric tools like Power BI, Azure Analysis Service, Azure Data Studio that can easily talk with SQL endpoints, but not with Apache Spark endpoints. Our goal is to enable all these SQL-centric tools to also access data that is created by Apache Spark. Therefore, we are replicating tables created in Apache Spark into Synapse SQL. So the table that is created in Synapse SQL has the same structure and reference the same data that reference original table in Apache Spark. This way, you can use Power BI, Analysis Service, or Azure Data Studio to query table in Synapse SQL, and this table will actually reference the same data that is used by table in Apache Spark. This way, we have full metadata synchronization and metadata sharing between runtime engines in Synapse Analytics. So as key takeaways, Azure Synapse Workspace is an integrated solution for data analytics that includes data warehousing, Apache Spark, Studio for creating scripts, notebooks, pipelines, reports, and pipelines for complex ETLs. SQL On Demand is one part of Azure Synapse Workspace that enables you to query various data sources such as Azure Data Lake and Azure Cosmos DB. Thank you for attending this session. I hope that this is something that will be useful in your future projects.